Hi there. In this video, we'll be talking about topic 4.1 of AP Chemistry's curriculum, Introduction for Reactions. So in this particular video, we're going to talk about what differentiates a chemical reaction from just a physical change. In other words, what's a chemical change versus what's a physical change. So before we can talk about reactions, let's just make sure you understand what a physical change is. So physical change. In a physical change, you have a change in the properties of the substance, so change in properties, but there's no change in composition. So a substance is exactly the same substance both before and after the change. So a couple of really common examples of this would be a change in state or a change in the phase of a substance. So when a solid substance goes to a liquid substance, melting, that still is the same substance before and after the melting. So if you take ice and you melt it into liquid water, it's still H2O molecules. We changed the properties, the hardness, the temperature, etc., the strength of the intermolecular forces, but we didn't change the composition. It's still water molecules. So any change in phase, whether it's boiling, melting, freezing, sublimation, all those changes in phase are simply physical changes because you still have the same substance. Another common physical change would be the formation or the separation of a mixture. So if you have a mixture of something and you take it apart, the substances in the mixture are still the same substances you started with. You've just now taken them apart from one another. Or if you form a mixture, you put two things together and they mix together, that also is a physical change. One thing about formation of a mixture that's a little tricky is if you dissolve a substance, especially an ionic substance, into water, it's hard to tell that it is not a chemical change because the solid substance has disappeared. You can't see it anymore, and it seems like it's a chemical change because you no longer have that substance visible anymore. But that's not true. When you dissolve something, you are just causing the ions to split apart and still float around as ions, but they're still the same ions. If we evaporated the water off, it would be very easy to get those ions to reattach to one another and form an ionic compound. If you've put a molecular compound into a solution, the molecules of the solute are attracted to the molecules of the solvent through intermolecular forces, and you still have the same substances. They're just rearranged and attracted to each other in a different way, but they are still the same substances. So be careful with that. Forming a solution can look like a chemical change, but it's actually a physical change. So now that we've talked about what a physical change is, what is a chemical change? Well, you can see the room for the contrast here. A physical change, there's a change in properties, but no change in composition. So a chemical change, there must be a change in composition. And that is the key. The substance is transformed into a new substance. And the composition the composition of the new substance or new substances is completely different than the original substance. So you have made a new substance. And key here with the chemical change is breaking bonds and forming bonds. If you break bonds within a molecule or within a compound, then you have made a chemical change because the compound is not the same anymore. If you form new chemical bonds, then you have undergone a chemical change because you've made a new substance. So breaking bonds and forming bonds is key in chemical changes. Now, there are some evidences to tell if a chemical change has taken place. One evidence is there's a change in energy, and this would be the form of heat or light typically. So if heat is released or if heat is absorbed, then you have pretty good evidence that bonds were broken or formed because breaking bonds absorbs heat and making bonds releases heat. So that's an evidence that energy has changed. You have to be careful with this one too, because when you dissolve something, when you make a solution, energy changes also, but that's just a physical change. So you have to be careful with this one. And then light, like glow sticks, produce light. That's evidence that a chemical reaction is taking place in there. Another evidence of chemical change would be formation of a gas. So if you put two things together, like two solids or two liquids together, and all of a sudden a gas is formed, then that gas is a new substance. It obviously wasn't there before, and now it's there, so you've made a new substance. Again, you have to be careful with this one, because if you boil something, of course, boiling makes a liquid into a gas, but that gas is the same as the original liquid, so that is not a chemical change. What we're talking about here is if a different new gas is formed when two substances are put together and react with one another. Third evidence of a chemical change is formation of a precipitate. Formation of precipitate. Remember, a precipitate is a solid that comes out of solution when two solutions react with one another. The ions bump into each other and form a ionic solid. That ionic solid is the precipitate. This is a powdery, cloudy substance that's formed when two solutions are put together. So that's another evidence of a chemical change, because you've made a new substance. And the last one, color change. If you make a new substance, the new substance might have a new color. And so if you see a color change, if you put two things together and a new color forms, then that's pretty good evidence that a chemical change has taken place, because you've made a new substance. So that is where we're going to stop on this one. If you have any questions, as always, please let me know and I'll be happy to help you out. Good luck.